The empirical formula of a compound is the smallest whole number ratio of the atoms present in the compound. Let's do two examples to show how we can calculate the empirical formula from the percentage composition. This question says a substance contains 25.3% magnesium and 74.7% chlorine by mass. What is its empirical formula? A technique I like to use is to draw a table and complete all the steps in that table, and this keeps everything organized so it is easier to write the empirical formula once the calculations are done. Let's start by drawing two columns, one for each element that is in the formula. So we have magnesium and chlorine. The first step is that we're going to assume that these percentages are actually just masses and the total mass is 100. So we'll write the mass, which is 25.3, 74.7. Second step is to calculate the number of moles. Now to calculate number of moles, we divide the mass by molar mass. The molar mass for magnesium is 24. So we would divide 25.3 by 24 and we will get 1.05. Next, we would divide the mass of chlorine by its molar mass. The molar mass of chlorine is 35.5. If we divide 74.7 by 35.5, we get 2.10. Our next step is to determine the mole ratio. And to determine the mole ratio, we would divide both numbers by the smaller number. In this case, the smaller number is 1.05. So if we divide it by itself, we get 1. And if we divide 2.1 by 1.05, we would get 2. The mole ratio actually tells us the number of atoms of each element present, so we could now write the empirical formula, which is Mg1. You know we don't write 1 in the formula, and Cl2. The empirical formula for this compound is MgCl2. This question says nitrogen and oxygen form an extensive series of oxides with the general formula NXY. One of them is a blue solid that comes apart reversibly in the gas phase. It contains 36.84% nitrogen. What is the empirical formula of this oxide? Again, we can draw our two columns. We know that one element is nitrogen and the other is oxygen. Our first step, we equate percent to mass, and it tells us that the percent of nitrogen is 36.84, but it does not tell us the percent of oxygen. This is simple to find out because percent means out of 100. So to find out the percent of oxygen, we'd simply subtract 36.84 from 100. When we do that, we'll get 63.16. So we have our mass. Second step, we should find the moles. And as usual, we find our moles by dividing the mass by molar mass. The molar mass of nitrogen is 14, so we'll divide 36.84 by 14 and we'll get 2.63. The molar mass for oxygen is 16, and when we divide 63.16 by 16, we'll get 3.95. We'll then find our mole ratio. This is done by dividing the number of moles for each element by the smaller number. In this case, the smaller number is 2.63. When we divide it by itself, we'll get 1. And when we divide 3.95 by 2.63, we'll get 1.5. And I'm just going to pause here for a little to say, when you're calculating your mole ratio, you only round off if the number is already close to a whole number. But if you get 1.5 or if you get 2.5, anything 0.5, you're going to keep that 0.5 in the figure. Don't round off there. How you correct that is you'll have to multiply by a number to get a whole number. And we know that 0.5 times 2 would give us 1. So we'll multiply both numbers by 2 and we'll get 2 times 1. 2 times 1.5 is 3. And now that we have both of them as whole numbers, we can go ahead and write our empirical formula. So again, mole ratio tells us how many of each element is there. So our empirical formula is N2O3. Once the empirical formula of a compound is found, we can use information from that and it's experimentally determine the molar mass to find out the molecular formula of a compound. While the empirical formula only shows the ratio of the number of atoms, the molecular formula shows the number of all the atoms that are present. The empirical formula is like a simplified molecular formula. Now to determine the molecular formula, we'll first find the molar mass of the empirical formula. To find the molar mass, we have to add the mass numbers for all the atoms in the compound. From our empirical formula, we have mass number of carbon 12, mass of hydrogen is 1, but we have 3, so we'll multiply that by 3, and the mass of oxygen is 16, so the empirical formula is 31 grams per mole. Next, we'll find how many times the empirical formula is repeated to form the molecular formula. We do this by dividing the experimentally determined molar mass by the molar mass of the empirical formula. The experimentally determined molar mass is the one given in the question, so that's 62, and we're dividing that by the molar mass of the empirical formula, which is 31, and that gives us a factor of 2. Our molecular formula is therefore C2H6O2.